Dear students, welcome to the 5th session on galvanic cells, and this is the last session on galvanic cells. In this session, we will be dealing with reference electrodes and fuel cells. You have already seen one of the reference electrode, which is the standard hydrogen electrode, SHE, which can be represented as platinum in contact with hydrogen gas, which is maintained at a pressure of 1 bar in contact with a solution of H plus ions. Again, here the concentration has to be maintained at 1 molar. So, this is one of the reference electrodes which we have seen in detail, and in this electrode we have fixed its potential to be 0 volts for setting up a scale and preparing the electrochemical series. So, here we have a reference electrode whose potential is arbitrarily chosen to be 0. Now, why do we have other reference electrodes? Here the difficulty is to keep the hydrogen pressure at 1 bar while it is being bubbled through H plus ions. It is very difficult, and to maintain it accurately at that pressure, and therefore, when we couple this electrode with another electrode for measuring electrode potentials, it will affect the potential measured. So, we are going for some other reference electrodes which can be easily set up, and we can use it as a reference electrode. Now, we have two types of reference electrode, that is, one is the standard hydrogen electrode, which we call to be a primary standard electrode, primary standard reference electrode. Okay. So, this is a primary one. Now, combining this electrode with certain other electrodes, we are going to fix their potentials, and using that electrodes you can measure the other electrodes whose potential has to be determined. So, we are going to find out some of the electrodes which are to be set up easily and conveniently used, and such type we call them to be a secondary electrodes. And if it is in standard conditions, you can have it as standard one, reference electrodes. So, we have two type of reference electrodes, one is the primary, and we have only one primary standard hydrogen electrode, that is SHE, and you can have some of the reference electrodes which can be easily set up and used for experimental purposes. So, let us see what you mean by a reference electrode. Reference electrode means it is an electrode whose conventional potential value is accurately known. It should be accurately known, and by coupling this electrode with another electrode whose potential is unknown, you can find out the potential of the other electrode. Such electrodes are known as reference electrodes. Now, there are several electrodes other than standard hydrogen electrodes, and we will just discuss the name of two, and we will be discussing in detail one of the electrode. So, here one of the secondary or subsidiary reference electrode is the silver chloride electrode, which has a potential standard potential of 0.224 volts. Standard means, I think you remember, the concentration has to be 1 molar, and here since there are no gases, only the electrolyte concentration has to be maintained at 1 molar. So, it is easy to set up, and the electrode reaction for this will be, as I have told you, you have to identify where we have the oxidized state, and that is in AgCl solid, that is a metal insoluble salt, plus here Ag has got only one single positive charge. So, we require only not 2 electrons, we need only 1 electron, one electron which reversibly gives, here Ag is in the oxidized state, it takes up the electron and gets reduced to Ag metal solid, plus the chloride ion goes into the aqueous solution. Okay. So, this is the electrode reaction, which is shown in the form of reduction, because I am considering the single electrode. So, this is one of the secondary reference electrodes, which can be easily set up. Just dip a silver rod into a silver chloride paste with any of the chloride ion solution. It can be potassium chloride, sodium chloride, whichever you like, and then insert the silver rod through which you can take the current outside. So, this is which can be easily set up and used for practical purposes. Now, another one which is also known as the calomel electrode. The calomel electrode, as you all know, we have already seen as an metal insoluble salt, but here it is obtained in a fixed form, the calomel electrode. You just take the calomel electrode, you can club it or attach it any other electrode very easily, and this is the most commonly used electrode as a secondary reference electrode. Now, calomel electrode, again it belongs to metal insoluble salt type of electrode. Here we have mercury, mercurous chloride, which is otherwise known as calomel, and a solution containing chloride ions, and here it is fixed as potassium chloride, and this electrode is known as calomel electrode. So, this is how you are going to represent a calomel electrode. A schematic picture of calomel electrode is shown below. See, it contains a glass tube which contains mercury at the bottom. So, the glass tube is filled with mercury at the bottom. It has got two side tubes, that is, one side tube which is bent right angle and has a jet type at the tip, and it is plugged with glass wool. The other one is a normal side tube. Now, above the mercury, I will keep a paste of mercury and mercurous chloride. Mercurous chloride means calomel. Okay, we make a paste of mercurous chloride and mercury, just put it on the top of mercury, and above that, which is shown in this black color, that is potassium chloride solution. Okay. So, this is one way, and the potassium chloride we have to fill potassium chloride to the required extent, so that it should be above the level of this side tube, bent tube, because this is the portion by which we are going to attach it, just like a salt bridge is put in another solution of the electrolyte, to which we keep the electrode whose potential has to be determined. So, this is through which we will attach it to the other electrode, and potassium chloride is usually filled through this side tube whenever it is required. Now, to make electrical contact, we have a platinum wire sealed in a glass tube, so that from here you can take the connection to the external circuit. So, this is a setup we have for the calomel electrode. So, you get it, prepare it, keep it, you can use it with any other electrode. So, very easy and convenient way to keep a reference electrode. Now, let us see what is the electrode reaction in this case. Here we have to take calomel, in which you will get the oxidized form of mercury in this. So, calomel will take up, here we have two mercury each in +1 state. So, you add up 2 electrons and you get mercury liquid, and since 2 Hg, because we have 2 mercury here, plus the 2 chloride ions are released into aqueous solution. So, this is the reaction. Now, this electrode is reversible with respect to chloride ions. It is reversible with respect to chloride ions or the anions involved. Now, here one thing you have to understand is that you take mercurous chloride, it is in the solid form. mercury is 100% pure. Now, the potential of this electrode then obviously depends upon concentration of the chloride ions. Okay. So, if we change the concentration of chloride, that is here instead of chloride ions I can say KCl solution, because it is from KCl we are getting the chloride ions. Once the concentration of KCl solution is altered, its potential varies. We can see how it varies and what are the values. See, if I am taking a 0.1 normal potassium chloride solution, its potential is 0.339 volts. Now, I can take another concentration, that is 1 normal. It is also known as normal calomel electrode, NCE, that is a short form used for normal calomel electrode. If I am taking 1 normal solution of KCl, its potential is 0.2900. So, see, when the concentration is altered, its potential changes. You can also do it the other way. You take a saturated solution of potassium chloride. When we take a saturated solution of potassium chloride, what happens is again its potential changes. It becomes 0.2415 volts. So, depending on the concentration of potassium chloride, and this is fixed, and these values are supposed to be at the temperature of 298 Kelvin. So, you take calomel electrode, you can choose potassium chloride, and to set up easily what we go for is a saturated calomel electrode, SCE. This is a commonly used one. You prepare a saturated solution of potassium chloride, keep a bit of potassium chloride extra, so that it keeps the solution saturated. You fill it, you have a saturated calomel electrode. So, very easy to set up, and usually it is taken as 0.2415 volts for that. Next, we will see a new type of cells known as fuel cells. We all know what is a fuel. Fuel is usually we burn it, and from that we will be getting heat energy. So, fuel is a substance which burns and gives heat energy. Now, what about fuel cells? Here also, that is, it is a reaction equivalent to burning, but it does not burn. It really, burning is a process in which a substance gets oxidized to its oxides. Okay. So, here again you can say there is an oxidation taking place, there is a combination with oxygen, but instead of producing heat, you will be getting electricity. So, that is a very novel idea, and it is a recently developed idea of fuel cells. And one of the easiest and the simplest form is hydrogen oxygen fuel cells. There are other fuel cells using hydrocarbons and all those, but here hydrogen oxygen has got very good appreciation in the sense the byproducts formed are eco-friendly, because we all know that hydrogen burns in oxygen. If hydrogen burns in oxygen, what will be the byproduct? It is usually water. And that is 2H2. Okay. So, it is eco-friendly also, but there is one more difficulty, that is storage of hydrogen is a bit dangerous, especially in a climate like our country, where the temperature goes up and hydrogen is easily inflammable. Now, let us see how to represent this hydrogen oxygen fuel cell. We have a graphite, which is one form of carbon, then hydrogen gas in contact with NaOH, which is an electrolyte which contains hydrogen, okay. And also the other side, the electrolyte is NaOH itself. So, you have only one electrolyte, that is NaOH, which is common to both hydrogen part as well as the oxygen part. So, both of them have the same electrolyte. You do not have separate electrolytes for the cathode and the anode. And by writing this itself, we understand that the hydrogen part undergoes oxidation, because this will be the anode, and oxygen part will be the cathode. Now, let us see how is it a schematic representation made. See, this is how it is. These are the two porous graphite sheets, that is separating the that is we keep the electrolyte in between these two. So, these are the two graphite porous graphite sheets, okay, and this act as the electrodes. Now, what we do is we keep the alkaline solution, usually sodium hydroxide is kept here, because sodium hydroxide is more cheaper than potassium hydroxide. So, we prefer sodium hydroxide as electrolyte, which is kept in between these two graphite electrodes, and this graphite electrodes, they are impregnated with platinum. That is for just a catalyst activity, so that the reaction between the gas occurs easily. Now, through it is again enclosed in another vessel, which you can see through the upper inlet you feed in the hydrogen gas and water flows out from the lower outlet. In the similar way, you can see on the other side oxygen is fed in from the upper inlet and water is removed from the lower outlet. So, this acts as an inlet and this as the outlets. Now, here when hydrogen enters here, since this graphite sheet is porous, it passes through it and bubbles through the NaOH solution or potassium hydroxide solution, whatever you have taken. In this side you have oxygen which goes inside the pores of this diaphragm and then gets into bubbles into the NaOH solution. So, both hydrogen and oxygen, they enter through the graphite electrodes to the alkaline solution, and here occurs the electrode reaction and potentials are developed at both the electrodes, and you can connect it out and take the potential. Okay. Now, one more difference from ordinary electrochemical cells. Here the other thing, when we have taken Daniell cell or any other cell, what we do is we have the electrolyte and all the reacting substances taken first, and it is set up the the cell is set up. In this case we do not do like that. It is continuously fed, that is the reacting substances, that is hydrogen and oxygen, they are continuously fed in and you derive the electrical energy from that. Once you stop, the cell stops. Now, let us see what are the electrode reactions taking place. Here hydrogen, which is acting as the anode, it combines with 4 OH minus ions to give 4 molecules of water and 4 electrons are released. These 4 electrons are taken up by oxygen along with water molecules to give 4 OH minus ions. See, here 4 OH minus ions are consumed and here 4 OH minus ions are released. So, the alkali is not being used up, it is taken and then regenerated. And the overall cell reaction is, you can cancel all the common terms, and finally, you get the cell reaction as hydrogen combining with oxygen to give water, and instead of producing heat, what you are going to get is electricity. So, it is a very novel method. Here the potential of the cell is 1.2 volts and it is a very convenient one. The only defect it has been found is the storage of hydrogen gas. Now, this is hydrogen electrode and there are further electrodes used instead of hydrogen. They have been using hydrocarbons also in the fuel cells, and researchers are going on. And Apollo, the mission, we had space mission, it was powered by this hydrogen oxygen fuel cells, and some of the warships, then submarines, they all use this as a alternative power when they are going under the sea. So, this is a field for further research and development, and it is going on. Now, advantages of this fuel cells. Ordinary cells, they have an efficiency ranging about from maximum to about 60%, And fuel cells, they have got very high efficiency of 60 to 70%. They are very light, as we know what we have is the hydrogen and oxygen gas, and it is very light. Since no direct combustion is involved, they serve as a pollution free source of energy. So, these are the main 3 advantages of fuel cells. So, in this class we have been seeing reference electrodes. We know already there is standard hydrogen electrode, which is the primary reference, but it is very difficult or inconvenient to set up hydrogen electrode. So, we go for secondary reference electrodes. We saw 2, one is silver chloride, the other one is the calomel electrode. And then we have seen the fuel cells, where the oxidation taking place is allowed to occur in an electrochemical cell, and from which we are deriving electrical energy other than for heat energy, and it is a eco-friendly. Fuel cells are used for many purposes too. That is all for today. Thank you.